8s. Today we are going to be doing some work with the Pythagorean theorem and your friend the clown. Okay. The clown will now get out of the way so we can look at a real world problem. In this problem, they're giving you an example where someone needs to know if they meet the legal height requirements for a ladder. If you look over here, it'll say that the roofer has a ladder that is 12 meters long, which we have put on here. Is this ladder of 12 meters long enough? The roofer needs to tar a roof that is 10 meters above the ground. So this line going up is 10 meters. Safety standards suggest that the top of the ladder needs to go 1 meter above the top of the wall. So notice I have added that little piece in. At the foot, also the foot of the ladder must be at least 1 meter from the base of the wall for every 3 meters. So if we went up 3, 6, 9, it has to be at least 3 meters out from the base of the wall. Looking at this, some of you are going to think from yesterday, oh wow, I think I recognize this relationship. It has to do with this Pythagorean theorem. Yes, this is a little bit messy. I tried to do this lesson once before and my phone crashed. So if we look at square 1, which comes off of side A, and we look at square 2, which comes off of side B, the area of square 1 plus the area of square 2 equals the area of square 3, which comes off side C. So really what we're saying is a squared plus b squared equals c squared. So the area of this to the area of a squared plus the area of b squared equals the area of c squared. Okay. So what we're going to do is we'll figure out this answer in a moment, but if we flip this over and try some questions, what we've got here is we've got our right angle, and notice that this only works for right angled triangles. It will not work for anything else. Okay. So if we have a right angled triangle like this, here's my right angle. C is always across from the right angle. Okay, the other two doesn't matter. So we'd look at A, we could say something like A is 8.0 squared plus B, which is 6.0 squared, equals C squared. Then 8.0 squared is 64, plus 6.0 is 36, equals C squared. 64 plus 36 is 100, equals C squared. How do I get rid of a squared? Well, I take the square root from our first lessons of the year, and we end up with just C, and C must equal 10. So we'd come up here and say, I get it, that has to be a 10 centimeter side. Works perfect. Then if we come over here, we could change things a little, and notice this time we've given you the value for C. And these could be A and B. This time we're missing B, so let's try it anyway. So A is 3 squared plus B squared, which we don't currently know, plus C squared, which is 12.0 squared. So this time 3 squared is 9. You don't know B squared, so we're going to add that in, equals 144, 12 times 12. So now we have to do some simple algebra. So to get rid of 9 here, we'll take it away on the other side. So B squared equals 144 minus 9. So B squared equals 135. To get rid of the squared, we need to take the square root of both sides, and we get B equals 11.61. So if we took a look at this, that's our answer for up here. We would say 11.6. If you look at this question, this area, the relationship here looks very similar to what we had here. We have a 12-meter ladder. We have 3 on one side, 10 on another. Here we have 3 and 11.6. We would be able to calculate, is this okay for this guy to have this ladder, and will it work? Those are reasonable questions to ask. Those are reasonable questions to expect. And you could see that this is a reasonable, real situation that you could use this for. So grade 8s today, you have a bunch of questions to work on. They're all relatively simple, involving either this calculation or this calculation. You will be handing them in, not for evaluation, but for completion. And we will be doing some sort of quiz very soon thereafter. Good luck, and let us know, of course, if you have any problems. Roar.